Hi, this is a video about a method of analyzing graphs in math or physics. To start off with, you can see that we have a graph in front of us. I want you to take a moment to look at the graph carefully and identify at least three things that you notice about just like what you can see. We can do this like Dora the Explorer or something where I wait for you, or you can pause the video if you want to. But you should look for at least three things that you notice. Now that you've given yourself a chance to think, I can identify three things that I think are important. One is this point here that's labeled B. And another are these two lines. There are actually two lines that look slightly different. They both look approximately straight to me, or for all I can tell, they look very similar to each other. And they both look like lines I could draw with a ruler. One of them is red and the other one's black. And I noticed that there's an axis down here. If this was a position versus time graph, then the horizontal axis would be time values or clock reading values. So one third thing that we would want to notice about this this clock reading axis is that it's not a very large time interval that's shown. That is, it's the total time interval that's shown is about 0.2 seconds, which is like a fifth of a second, like not very much time at all. So just from these three things that hopefully you noticed about the graph, we can start to develop an understanding of this method of analysis that we're going to call a tangent line. The red line that you see is in fact a tangent line for the black line. And it's important to notice at this point that they both look straight. But if I zoom out of this graph, you'll start to see that one of them is not so straight. That is, the red line looks still pretty straight, but you're starting to be able to see that the black line is pretty curved. And in fact, if we zoom way out, you can see that the black line is quite curved. Again, if we think of this as a position axis and a clock reading axis, this could maybe be in units of centimeters and this could be in units of meters, but you can see that this black line represents something that is not traveling with a constant slope. That is, like the change in the position value as the clock reading value increases is not consistent, as we've seen with constant velocity graphs, which tend to be a straight line. The red line, however, is important for analyzing what is happening at an instant in time or a moment in time at a specific clock reading according to the black line. Now, if we think about the things that we noticed about the red line and the black line when we were zoomed in really close, I want you to make a prediction of what is going to happen to the red line when I move this point back and forth along the line. That is, like I can actually click this point and drag it up here and drag it down here. And I want you to think about what will happen to the red line based on what we've seen so far. We don't have any specific rules for making tangent lines. That is, this red line is called a tangent line. We don't have any rules for making them. But I want you to just at this point make a guess of what you think is going to happen to this red line as I move back and forth. Again, I'll give you a moment to do that. As I move this point from here to here, you're going to guess what the red line is going to do. If you want to pause the video, that may be a good idea. All right, I'm going to try it now, and we'll see how your prediction matches up with what happens. If I drag this over here, you can see two really important things that I notice. You want to think about whether this matches the prediction that you made or not. But two really important things that I notice are, one, that the point stays on both of them. That is, like the point stays on the black line and the red line adjusts itself so that it goes through that point as well. This is one important factor about tangent lines, that they have to intersect, the red line has to intersect the black line at one point, which is labeled B on this graph. The other thing is that it's still true, even if we move the point up here, that if we zoomed in really close on this point of the graph, that they would both look approximately straight. That is, it's still true even though I've moved this point B, that if I zoom in really tight to a very narrow range of clock readings, a very narrow time interval, the red line and the black line look very close to each other. And most importantly, the red line and the black line have the same slope according to this graph that we can see right here. I'm going to zoom out again so that we can move back and forth a little bit more. The final piece for a physics class in thinking about why this red line is important is to think about what the slope of a line on the position versus time graph, whether it's the slope of a tangent line or the slope of a curved line like this, what the slope means. It's like, can we make a statement to describe the slope? What are the units of the slope? If something was actually moving according to this red line, like what would we know about that motion? I'm not going to answer this question for you, but it is going to be a really important thing about thinking about what tangent lines are useful for. And think back to what we know about constant velocity motion, the graphs that we've seen of position versus time for constant velocity motion. So hopefully this gives you a better idea of how tangent lines can be useful and how to make them on your own. By the way, one good way to make tangent lines, if you are asked to make tangent lines on your own, is to, if you don't see this this red line here and you're asked to make it, you can kind of take a ruler and hold it up to the curved line that you're analyzing, and make sure that the line that you draw with your ruler touches the other line at one point, like we said, and that the slope is approximately the same as the slope of the curved line at that point. One good thing to look for is if like this kind of angle that you see on this side is approximately the same as the angle that you see on this side. Also, one good guideline is that your tangent line shouldn't actually cross the line. There are exceptions to this, it's not a rule, but especially if you're looking like nearby the point, you shouldn't get a line that actually crosses the black line. You can see if we were to make this red line steeper, it would actually cross from the bottom of the black line to the top of the black line. We never want to see that when we're analyzing a graph like this. We always want the tangent line to remain on one side of the black line, of the curved line, but to go through that one point.